Hello, good afternoon. I think it's in live. I think it's on live. Let me know if you can hear my voice. If there's no problem, I would like to start the live. Good afternoon. Hello. So, this is Junichiro Horikawa, and this is a weekly tutorial live for Houdini, which I have started continuing from last week, which I am showing some algorithmic design techniques each week with some topic. And today what I would like to show you is to create this kind of sci-fi like circuit network, procedural circuit network, which I am going to show you how you could, what's the algorithm underneath of this and how you can create it, and possibly be able to create a growing animation like these on top of a given grid. More of a network which goes straight in diagonal directions like a maze, and you can change some C's to randomly generate using the same rules like these. Or you could also have some parameters to tweak how much turns you want to achieve for these lines. For example, if you have more straight lines going from top to down, you can increase this directional power, which will give you more straight looking lines like these. If you have more of a swirling curves, you can decrease this directional power like to 1 to have more swirling like pattern. And if you want to have more, I don't know, how do I say it? A perpendicular turns. Right now it rotates with the diagonal diagonal direction using 45 degrees, but if you want to have a 90 degrees turn as well, you can increase this directional minimum value a little bit. To have more of these 90-degree turn, and combine with this directional power, it will give you some other kind of feeling. Okay, so that's what I'm going to show you, how you create this and how you can also create this kind of a growing animation out of this. Okay, hope you find it's interesting, and let's get to this. One disclaimer about this is that you do need to do a lot of codings for this one. You do need to make write your own logics a lot, especially inside this feedback loop. So I'm gonna try to explain from scratch how you can do this. Alright, so first of all, let me show you some underneath algorithm how you could do this before getting into the detail first. So let me try to draw some sketch. Okay, so first thing first, what I want to give is a grid, the base grid, which is going to use it as a base to run the path, the circuit path. So it will be a 2D grid, something like this. And first thing to do is to define which point to start growing the path. So in this example, I have chosen all the points on top of this grid to be a starting point. which goes from top to bottom initially, and then at some point goes directional turns like that. Okay, but the problem is that you don't want to start these points simultaneously at the same time, but you kind of want to make some time gaps between these points to start growing, so that because if every point starts at the same time, it just goes downwards all the time, and you're just gonna get this vertical lines in the end. So that's not what you want, but actually what you want is first start growing the lines from one of the point, maybe like this one, going downward, and when it comes to this the first intersections, you want to make this curve turn left or right or downward or 90 degrees or 45 degrees randomly. Pick randomly which ways you want to turns. So pick randomly like that, and continue doing this. At some point, all of those rest of the points will start to create the turns like these. Okay, and in the end, the grid will be filled with these lines. And after the first initial endpoint has been used up, there are some leftovers, so that's where you want to respawn the starting points at some random position again. So maybe after this point, this circuit lines has come to the end, where there's no way to go to at the end, then you can spawn another point somewhere around here or here or here, anywhere to redo the same path creation again and again until it could somehow fill up the grid. Okay, so that's the rule, that's the basic rule here in order to create the path. And let's see how we do this from scratch. Alright, so let's go to grade. I'm gonna start by creating a grid, and let me also save this to the today's folder. Okay, so I guess the first parameter you want to have is to define the resolutions of this grid, like on the x direction and y direction. It will be the number of, it can be the resolution of the path itself. So let's define that first by having some global controller. I am going to create a null which will contain all the parameters that I want to control in this project. Let's call it this controller, and I am going to create two integer parameters to define the number of grid on x direction and y direction. So grid x, grid x, and grid. And let me know if you have any questions during the live. Okay, from 0 to, let's say, from 100, 0 to 100. Right, so let's start from small, like number of grids, to make it faster to operate, faster to compute. So let's start by 30 by 30. Copy this parameter, and for the x value goes to the column, and the y value comes to the rows. And I think it'll be a good idea to change the grid size as well based on those rows and number of rows and columns, just this one. So let's copy the columns and use this for X size. Probably it makes sense using -1 so that the one cell become the size of 1. Okay, same as Y, copy the rows and paste it to the Y size and -1. That way you always get each cell size equal to 1 on the X and Y. So let's try this. If I change this, okay, looks good. Okay, so I'm gonna keep this to 30 and 30. Now, initially it's good, but since I also want to create a path, a diagonal path, which goes from this point to this point, or this point to this point. So you also, right now you only have this perpendicular or horizontal connections between the points with this grid. So what I would like to do is to add additional connections to this grid, which will be a cross lines, goes from this point to this point and this point to this point for each primitive. Okay, so let's do that. I am going to do that by using a primitive wrangle. Probably there are many ways without the coding, but I'm just gonna do it this way. Let's name this cross lines. So the idea is the primitive wrangle runs on each primitive, which is these squares. And I'm going to first pick up these 4 points from this primitive in an order, maybe clockwise order. So let's say this will be the 0, 1, 2, 3. And by picking up 0 and 1, you can create this diagonal lines, and picking up number 1 and number 3, you can create another cross lines. So that's what I would like to do. And in order to get the points in a clockwise order from the primitive, it's always a good idea to pick a vertices numbers out of primitive instead of getting a primitive points. So prim vertices from a primitive, and possibly you get 4 or 5 points out of each primitive. In this case, 1, 2, 3, 4, 1, 2, 3, 4, 5. So the last point is you don't need to care about the last points if you have 5 points. Okay, so what I'm gonna do is to create a for loop. Since we only want to have 2 cross lines or diagonal lines from one primitive, I can just say that there's only 2 loops is needed in this case. Okay, and then get the first vertices, a vertex number from a VTS, and second one VTS I plus 1 and modulus by length of VTS, just in case, so that it can go back to 0 after it reaches to the maximum number of the array lengths. And then now this is just a vertex number, so you want to, in order to create the lines between 2 points, you want to convert this, so you want to get the point number out of these vertices. So let's get that by vertex point, using vertex point to convert vertex into point, like that. Vertex point. Okay, now that I have 2 points, I can now create a line as a diagonal line. So add prim polyline pt1, pt2. Alright, I think I have just added the cross lines. It's a bit hard to see because I have these faces, so let's delete those faces by using a convert line node to convert all the faces into the lines. Oops, okay, I think I'm missing something. Alright, I don't see it. Let me see if I can recheck. And vertices, let me see if the primitive number having been increased. Yeah, it has been increased, so seems like I am getting the wrong number for these points. It's okay. Add prim 0 polyline looks correct to me. Okay, this one is wrong. So as I said, you have to get the diagonal point numbers. If the point is equal to 0, then you have to have 2. So you have to add 2 to this. Sorry for that. And then, oh yeah, looks correct. Okay, so that's the cross lines. Now, I would also like to set some initial attributes to each point. Now each point is going to be used as a candidate for the points to go to. So so I would like each point to have some kind of starting ID values. Okay, so let's do that by creating a point wrangle. Right, let's name this initial setup. Okay, and there are several stuff that I need to set. Well, let's start by a small number of setups and maybe then increase it later when we need those informations. Okay, so first of all, we need to define which point will going to be used as the starting point to create a circuit path. Okay, as I announced in the sketch, I would like to set these points on the top corner or top edge to be the starting point. So let's see how we can find those points. I mean, there are several ways you can just manually pick up, but in those ways you cannot procedurally chosen when you change the grid. So let's think about algorithmically. In this case, it is placed on the minimum z position of this bounding box of this grid. So let's get the bounding box of this grid and then compare the minimum z with the current point z value, and if the value difference is minimum equal close to 0, then that's the point you want to pick. So let's do that. I am going to get the minimum value and the maximum value out of the get using the get bounding box. Which in this case, if you do this, the minimum and maximum vector will be filled up with a minimum point position and maximum point position of this grid. So in this case, the minimum should be somewhere around here, the maximum should be somewhere around here. If I'm looking at this axis, this is the x-axis, the right direction is the positive, this is the z-axis, the down direction is the positive. So this is the minimum, this is the maximum. So I would like to get the z minimum to get those points on the top. So min z is what I want, and what I would like to do is to compare this with at p, which is the current point positions z, And I'm just gonna create the differences by subtracting and calculate the absolute value just in case. And then if it's close to 0, that means you are getting those points. Okay, I guess there are some smarter way to do this, but let's just do it this way. Okay, so these are the points that I would like to make it as a starting point. So let's set it as some group. So I'm going to name these as endpoint, which is going to be the end of the circuit path. So set point group 0 end and at ptnum 1. Okay. And all right. Another value that I would like to do is to after I have run the simulations, I don't want to have any intersections like the other network goes on top or just touches to the other network. So in order to avoid those, you do need to set some value to each point, whether it has been visited or not, it has been used or not. So I'm gonna use another group to named as visited to define that this point has already been used by other network. So visited right. And I also want to have another attribute value for each point, which is going to be the ID, to define the ID for each circuit path. So also in order to find out which point belongs to which circuit path. So I'm gonna create an ID from the point number in this case. So ptnum, like that. Right. Okay. Another value that I would like to set to each point is the starting time, when to start growing the line. As I said, if you make these points grows at the same time, it just goes down directly to the down directions, just gonna be straight. So in order to create some kind of a randomish network, you want to have some gaps when to start those points for each lines. So that will going to be the time difference or starting frame differences. Let's consider it as a animation, and let's think these frames as a starting point. So some points will have a value equal to 40. That means those point only starts growing after frame 40. If it's 0, then starts from the right right off. If it's 90, starts from 90 frames and so on. So let's create that kind of offset time range times frame to each point as an integer. I am going to name it as a start frame using a random value based on the positions, and probably having some random seed is a good idea so that you can have some variations. And since random just gives you a value in between 0 to 1, I need to multiply this into a maximum frame value. So let's multiply this, and this starting time range can be any value, so let's make it parameterized as well. So time start frame range. Okay, so we have two parameters, one is seed, one is start frame range. And at last, it might be a good idea to make it round value to make it as an integer using rint. Okay, now we have two values. Let's increase the range. The seed can be any number, so I'm gonna make it from 0 to 10,000. The start frame range might be a good idea to make it from 0 to around 200 for now. Okay, so let's give the start time range frame range to somewhere around 50, and let's also have these value copied to these controller. Right, so uncheck 4-bit linking parameters of outside subnet and drag and drop those values. Let's rename this random seed and start frame range, start frame range. Okay. Okay, thank you for Cyphers, thank you for the shortcut. I add group name. Yeah, sounds like a good way to apply a group value. I'm gonna try that from next time. Okay, so there. This is ID for each line's pass. This is a starting frame number. Okay. And the other information that I would like to have is a bit of special one. If I go back to the sketch and let me see what I would like to have as another value. So let's see if we have a grid. Oops. And what I would like to have as this kind of a sci-fi like circuit network is to have us to run the network as much as possible to the same direction for a long time. Like for this point, if I start from this point, I don't want to move this point like jiggering around like these randomly, which will be not really preferable. But what I want to have is network something goes like these, trying to preserve the direction which has been used previously. So if it comes from this point to this point, then the previous direction is like this, and for the next pass I want to use this information and use that to define the next direction. And if the next direction is close to this one, you'll have more chance to go to the same direction, and maybe a less chance to go to the other direction, like from this direction to this direction, and much less possibilities goes from this direction to this direction, like that. Okay. So that way you have more cleaner network, clean sci-fi like network, which seems like it goes from top to down with nicely aligned curve. Okay, but also you can tweak that information using some assigned parameters. So that's the thing that I would like to control. Try to use the previous direction to define the next direction. Okay, so let's see. So what I would like to have now is the directional value to each point to starting point, named as probably dir, stands for direction. And in this case, I want to move the initial point to go downward. So let's create the vector value goes to down direction, bottom directions, which in this case is 0, 0, 1. Right. Okay. So that's the initial information, I think. Okay, so, and let's also think about the other points, what we need to do for the other points. First of all, we can set the ID as -1 for now, because nothing has been applied to any circuit paths yet. Let's do that like that. And also, let's set a group. Okay, I'm gonna try to use the one Cypher showed me. I at group I'm gonna create another group called unvisited to make it as one. Okay, let me check if I have got it right. I'm gonna open up the geometry spreadsheet. Okay, I do have it. Right, looks good. All right, everything is set. Now, I do need to set some other informations, but let's skip that for now and continue doing this. This will be the initial setup. Now, next thing that I'd like to do is to let's also get the, in order to respawn the polyline after you have created the, after some of the lines reaches to the end, in order to respawn, you need to create a unique ID for the next circuit path. Okay, in order to create a unique circuit path, you cannot use the same ID from last time. So in order to make it always unique, I think it's a good idea to get the latest or last number of the ID keep tracked. So in order to do that, I'm going to use, in this case, as an initial setup, I'm going to use the attribute promote to get the last number of ID out of each point, and get the maximum. I'm gonna name this last ID as a detail attribute. So from point to detail, I'm going to getting the ID and get the maximum, change it to last ID, don't delete the original, and looking at the detail, okay, so this will be the last ID. So the next circuit pass ID should be this last ID plus 1, which will be 30. Alright, so I think as the initial setup, this is enough. And it's time to actually create this network creation algorithm implementation. So there are two ways to do this. One way is to make it with the solver. Another way is to make it with the for each loop. Either way, you do need a feedback loop information in order to achieve what we want to have today. Solver is good if you want to create the animation, but there are some limitations when you want to check instantly the process. So I'm gonna start by creating the feedback loop using the for each loop, and if you like, you can also convert it into solver later. Okay, so I'm gonna use the for each number, and the number here indicates how many loops you're gonna get, and I'm gonna change this merge iterations to feedback each iteration, and also change the fetch the for each began to fetch feedback so that there will be a feedback loop. Okay, and I think it is a good idea to have this iteration as a parameter as well. So go back to the controller, add another integer value, iteration number, which indicates the total growth of the circuit path. More number you have, more longer network you have, more grown network you have. Let's set the maximum to 100 for now. And stop by something small, like 10. It's always good to start with the small numbers. And probably I'm gonna make this grid a little bit smaller, like 20 by 20, so that the calculation will be much faster in this case. Alright. Okay. Now I am going to first connect the null node inside each for each loop. I'm gonna name this info so that I can refer to this null node inside of for each loop using the expression maybe later. Maybe not. I'm not sure if I need that, just in case. Okay. Now, what I can do here is that I can simultaneously run the network growth for each endpoint, each point which has an end group. But if you do that, there is a chance that the network will touch to each other at some point, because let's say this point has an end group and this point has also an end group, and if this point and this point has the same starting frame value, which means it starts at the same timing, and if this one goes to this direction and if this one goes to this direction, then you already have some intersections. But there is no way to determine if there is an intersection or not if you do it simultaneously. So you don't want to do that. What you want to do is to run the growth for each endpoint one by one, step by step, or something more brute forcefully checking using another loop to look for each endpoint to run the growth. So let's have another for each loop. In this case, what you want to get is the number of live circuit path in this case, I think, meaning some of the circuit path has been reached to the end, and in that case I can say that this path has hit its life, so you don't want to run the simulations for that circuit path. But some of the circuit passes can still grow. So for those live circuit paths, I would like to calculate the growth. So in order to do that, we need to know we need to know which point is going to be used for the the next calculations. So for that, I think we need to use some filter, but let's see. In this case, I'm going to use the for each point and connect it right here. And okay, I think there is some problem here because it just converts everything to points. All right, forget about it. Let's say that okay, well, let's say I'm gonna use the for each number. Okay, another for each number, and oops, and this one will become a feedback loop as well. So oops, right now it's merged into each iteration, so it becomes a really huge loop. Feedback and feedback. Now the number of loops you want to have here is could be a number of circuit paths you have. In this case, the last ID will be the number of the circuit paths you have. Okay, right here. So let's have that apply to these iterations, which might not be a good way because it cannot, it will also include the dead circuit paths, but let's change that later. So I'm gonna try to get this last ID value from this info null node using the detail expression. Info last ID. So initially it's 19. You have 19 starting point here. So you have 19 loops inside. Maybe starting from this point, this point, this point, and so on. All right. Okay. Now, and let's also go back to the initial setup and set some informations to this end value, end group right here. So when the point has an end group, we also want to have an information if the point has been reaches to the end or not. Okay, so set point group 0. So let's name this as dead. And initially it's not dead yet, so let's set it to 0. Okay. And here I would like to have a point wrangle. First of all, I want to run the algorithm onto the end point and use the group end, and also check if the point is alive or not by using the if in point group 0 dead none is equal to 0. So if that point is not dead, then you can run the algorithm. Okay, and all right. So this will be the setup, and since having this code, it might not be a good idea to make it as an optimize. So if I have time, I would like to come back later to make it a bit more optimized so that I don't have to run like extra number of loops. All right. Okay, so inside this for each loop, what I would like to do now is to actually start getting the next direction and create a path. Okay, so that's what I would like to do. So in order to do that, let's say we are focusing to this point, and what we need to do is to first of all get all the neighbors from this point, in this case, this point, this point, this point, this point, and this point. Everything is connected with these lines. And out of these neighbors, you pick up the best candidates by using some random value together with this previous direction that I have set as a dir attribute. And using those two informations, I am going to pick the next direction. Let's say I pick this one and create a line. And in order to pick the lines, you also need to check if the goal, if the neighbor point has already been used or visited, or if there's an intersections and so on. And clearing all of that, if there are still leftovers within the directions, then that's when you can pick the neighbors, and that's when you can start keep growing. If there are no ends available, then no neighbors available for the next path, then this path was going to be dead and pass it to the next, spawn the next circuit path at some other points which is not still visited yet. Okay, so sounds a bit complicated, and it is a bit, but let's try to achieve that using Vex, right? Now I do use a lot of randomness inside here, so I'm going to, in order to create a random value for each loop iterations, I'm going to retrieve two iteration value from these two metadatas, meta node. I'm gonna connect this one to the second input, this one to the first input, the second input, and I'm going to just retrieve the iteration number out of these detail, which is going to be used as a random seed value later. Detail. All right. This is just my preference. There are maybe, sometimes you don't really need to do that. Maybe just using @p as a position as a random seed might be okay, but just in case. Okay, now first thing first, let's get all the neighbors as an array using neighbors function. Right. And let's loop through all the neighbors, and what we want to do is to pick the right candidate out of these neighbors to go to the next direction. And in order to pick that, as I said, you want to refer to the previous direction that you have set inside the point as a dir attribute. In this case, this one, dir attribute. So right now it's 001 for everything going downward. So the direction which is close to this direction will be picked up best compared to other directions. So this line is going to be picked up at the most ratio and this one will be the second most, and this one is the last, and probably not to the downward because there's no neighbors at all. So going back, make a loop. Okay, and pick the neighbor numbers, I guess. Okay, and so in order to compare the direction, we do need the directional values. So let's get the neighbor positions first of all. Add neighbor, and let's get the direction going to this direction from the current point position, and let's normalize this as well. so that it will be easier to compare. Okay, so in order to compare the direction, the easiest way is to use the dot product. The dot product between two vectors will give you a value in between -1 to 1. So let's say this is the original vector value, and let's say the next direction will be something like this. So when you calculate the dot product between this vector and this vector, which you move to the same origins, what you get is something in between 0 to 1. If the directions is the same, where did it go? If the two direction is the same, you get value, the dot product equals to 1. If the direction is perpendicular, the dot product is equal to 0, and if the direction is on the other direction, then you get value -1. So meaning if the dot product is close to 1, then you have more chance that you want to pick those lines. If it's close to 0 or -1, then less chance you want to pick those lines as a next candidate. Okay, so that's what I would like to get as a value. So float dot value dot product between the previous direction, which is applied as an attribute, and the current neighbor direction. Okay, and now this will be the dot value that I that I would like to check. And I don't really want to have a direction which goes something like this, so goes from here and goes like here, like turning more than 90 degrees is, I think, is too much for this kind of a sci-fi network. So I'm going to try to avoid having this line. So at least 90-degree turn is the maximum angle you get that I would like to get here. So in order to do that, let's create the conditions. If the dot val is less than or more than -0.1, then you can try to pick the direction. If it's less than -0.1, is meaning you get something like these, or you also get the direction goes to the previous direction, the previous positions, which is not also preferable. So in those cases, you want to just ignore it using it. So this will be this will indicate that you at least get the minimum or the maximum angle you get is the 90 degrees. Okay. Now with this, let's create let's try to pick up the value, the best value, but in order to do that, we do need to pick randomly which direction to go after all. So in order to do that, there are some tricks you need to do. What's wrong with this one? Okay, so in this case, let's say I'm starting from this point and this point there's a chance to go to this directions, and probably this lines which goes downward have like 50%, maybe this one 30%, and this one 20%, maybe 10, 15, 30 or something. Okay, in order to do that, one way you could do is achieve this, in order to retrieve a random value but using this kind of ratio, is to create tons of arrays which have tons of those options but based on those ratio. So let's say I'm gonna name these A, B, C, D, E for each direction, and you have an array, and more items you get, more chance you get out of this array. So in this case, C has the more ratio, so you insert tons of C's inside the array, and a little bit less B inside, and a little bit less D as well. And for the A and E, you have really small number of items inside the array. And what you want to do is to use some random values to create an index of this array, to pick one of the items, pick this one, or pick this one, or pick this one. And there, more items you have in the array, more chance you get to have this item using the random value. So that's what I would like to do here. From these ratio, I'm gonna create number of items inside the array based on the ratio, and then use the single random value to pick an index out of this array. So that if you have 30% number of C's inside the array, you have 30% chance to get C out of this array. Okay, so that's what I would like to do here in order to directionally or specifically pick some values randomly but with some ratio. I think this technique is being used in many computational design stuff, as far as I know. So I think this idea can be used in many places. Yeah, probably. Okay, so let's do this. So let's create a for loop to create a number of arrays, first of all. So int n 0, and what you want to have is to use this dot val as a ratio to create a same value for many times. So if the dot val is equal to 1, then you want to have the maximum number of you want to have a maximum number of items inside the array. If the dot val is equal to 0, then you have less number of values inside the array, and so on. Okay. So what I would like to do is to, for example, multiply this dot val by 100, so that if it's equal to 1, then you have 100 items inside the array. If it's equal to 0.5, you have 50 items. If it's 0 items. Now, sometimes if it's equal to 0, meaning if that's perpendicular directions. In this case, there are no items that's going to be created, so that might not be a good idea for a variation. So let's have a chance to pick at least a small number of values, even if the dot val was equal to 0. So I'm going to tweak this dot val using a fit function, which is initially it is in between 0 to 1, so I'm going to use a fit 0, 1, and what I would like to do is to convert it between some value larger than 0 to 1. So how do I name this? Min dot to 1. Could be 0. If it's equal to 0, you are going to ignore the perpendicular directions. If it's more than 0, you're going to include the perpendicular direction as a candidate. If it's equal to 1, then every value is going to be 1, so you have all the direction is going to be picked equally, as having the same chance to be picked, meaning you have more swirl-like trail, which might also be interesting. I'm gonna set it as 0.1 for now. Okay, I think I'm missing the dot val as a initial parameter. All right. Now, there is another value or calculations you could apply to this dot value. If you want to have more affections, more effectiveness to the directions, you could also apply some power functions to this, so that more close to a 1 you get more chances to get 1 value. If you have smaller than 1, then you have less chance to get 0.1 if you use the power value. So what I mean is to use the power functions, and initially it's 1, so it doesn't do anything. But if you increase this more and more, you get a curve. So initially the graph looks like this from x to y. Okay, but if you increase the power, then you get a curve like these, more and more. So more close to the 1, you have more chance to pick a higher value, higher direction, the directional value. And if it's close to 0.5 or 0, you get less chance. These area indicates the chance you get as a ratio. So if it's equal to 1, you have this linear chances. But if you use power functions, you get higher chances on higher value, less chances on smaller values. Now if you use power with smaller than 1, then the curve will become something like this. In that case, you have less chance with higher value, but more chance on smaller value, which could also be interesting. But probably most of the cases you want to use more than 1 for this power value. So going back, and let's have this as a parameter. I'm gonna name this dot power. Okay, let's promote those, and for this one I'm gonna set from 0 to, let's say, 20. All right, and starting from 2. Okay, now that I have this dot value, which is in between 0 to 1, and multiply by 100, it's time to have some kind of value inside the array. Now I haven't created the array yet, so let's do that next. Now in order to create the array, what you need is the array for the vectors, like which vectors you want to pick. In this case, this one. So you want to have a vector which collects this n directions, the neighbor directions to the neighbors. So outside the first for loop, I'm going to create the the array named as directions. And just in case, I also want to shuffle the array after it has been created. So I'm also going to create a another array for the float named as rands, which will have a random value for each item being created. Okay, so since this and this shuffle technique is also useful for many other purposes, I think, so I think it's a good thing to remember. So inside the second for loop, first thing I'm gonna do is to create a random value for the shuffling. So rand value is equal to rand based on the point position, and this is where I could use those iteration value for as a seed. So iteration 1 multiplied by some random value plus iteration 2 multiplied by some random value, and also we can use this I and n as well. So I multiplied by some, and this might be too much as a seed, but just in case that you get a really random value for each loop iterations inside this for loop and also within this feedback loop. Okay. Alright, so, and this will give you a value in between 0 to 1, and what I would like to do is to append this value inside the rands array that I have created. Right, so and later on I'm gonna use this rands for the shuffling the array. Okay, now I also want to append the directions inside the dir's array like this. Okay, now anything that I need to do, anything else that I need to do? I think I also need to I think I also need to have another array which will have a value for this neighbor number, which is this one. Okay, so let's have that as well. How do I name this? Picked neighbors. So array and append picked neighbors with neighbor numbers. Okay, so those are the three arrays that I have just inserted inside this loop. And as I said, more close to the previous direction, you get more number of neighbors, or more number of directions you get. Okay, now that I have a bunch of values inserted inside these arrays, it's time to shuffle these direction arrays and neighbors arrays because right now it's being inserted in a how do I say, in an order. Okay, starting from the smaller neighbors to the larger neighbors. But in order to pick random values from these array randomly, it might be a good idea to shuffle this after all. So let's do that by using this rands value. What I'm going to do is to first of all create a order integer or indices using an arg sort function, which will create a integer array to determine the the order of this random value. Since this is the random, the order is really random. Like the 3 could come first, maybe 1 comes next, 9 comes next, and so on. And I'm using this order value, I can resort these neighbor values and directional values, directional arrays. So to do that, you just do reorder. Oops, not picks, p-nays with orders and directions, reorder, directions, orders. Now using this, you could easily shuffle these arrays, and since I am using the same orders for the p neighbors and directions, it has been shuffled in a same order. Yeah, which is pretty useful. Okay, now let's try to actually pick the value out of these arrays. Okay, in order to do that, first thing to do is to check if the number of items inside the array is at least more than 0. So if the length of the p-nays or direction is 0, then you can pick some values out of these array. And in order to pick the array, you do need to have an index value, random index value. So let's create that value from another random value. So to do that, I'm just going to copy this random functions and just change those float value to something else. Anything is fine. Or you can just set a custom parameter as a seed for yourself as well. Okay, like that. And then since this is a value in between 0 to 1, let's create it as an integer value as an index. So random multiplied by the length of p neighbors Okay, and let's make this with the floor so that you can get an integer value. Okay, now this will become the random index value to get value from p-nays. Let's get that. So integer, I'm gonna name this pick is p neighbors index. Let's also get the direction as well. Direction, pick direction is direction index. Like this, right? And now that I have this, it's time to set this new point, this new neighbor point to be the new end point for the next growth point position. Okay, that's what I would like to do. So in order to do that, set point group to this named as end, to this pick point to be 1, and for the current, for yourself, you want to set the end point to be 0. I guess you can do that somewhere else, maybe not inside here. Okay, and set also since if the point become end, then that means the point has also been visited, so you do need to set the group visited as well. and if it has been visited, then you want to set the unvisited group to be 0. The reason why I'm having those two groups separated is because I'm also using this unvisited somewhere. Forgot where. Maybe it comes later. And you also want to set the ID, which is same as the current ID. So just pick the current attribute ID, and you also set you want to set the direction. So direction, pick P direction. Okay. I think that's pretty much it. And let's see if this is gonna work. Now, as initial setup, I think this is pretty much it. You do need to do a lot for other stuff later, but for now, for testing, I think this is all good now. And let's also set the current point group for the end. What was it? Group end to be 0. Alright. Okay, I think I'm some errors or spell mistake. And this one is okay, I don't have an I and N, so I'm just gonna delete these. Okay. Okay, so for now it looks good. I haven't set value dead yet to anywhere because I haven't determined whether the point has lost its way. Maybe you can do that by checking the length here. If it's equal to 0, then that means the point is dead. So maybe I can have that set here. So set point group to the, or it should be the current point, so I add group, what was it? What was the name? Dead is equal to 1. Yeah, let's see. So I've written this so far, and let's try if this is working or not at this moment. And this should recursively work if it's going okay. Now let's see. So right now I have 10 feedbacks loops, and if I look into the geometry spreadsheet, I have a bunch of directions applied, I have a bunch of IDs, and this ID indicates the same path that I want to connect. Okay, so let's try to connect these points which shares the same IDs, right? But there is a bit of problem because you don't really know the order of the IDs. So you cannot just connect these IDs right off the bat. So you do need to have, you do need to create some connections inside the loop. But let's just check what I mean. So let's see. The things that I need now is the point which is visited. So let's delete, or let's pick those points which have been visited using the point visited delete non-selected, and let's also just pick just the points and delete the lines. Okay, and using the add node, I'm gonna create a by group and by the attribute and connect the points that shares the same ID. Now, as I said, it is connecting something, it is creating some kind of connections, but it's just going wild. And that is because the point order is not based on the connection order, but it's more based on the grid order. So we need to fix that. There's two ways you can do it. One way is to set the order values inside the point, or just make a new primitive or new pass primitive which works as a actual network line. And I think the later one should be easier to control, so let's do that. So in order to do that, you do need to create this path from the first, from the initial setup. So that's where I want to go back, and going back to the initial setup, I am going to create some information for a path. Okay, what I'm going to do is to, for each endpoint, I'm going to create a new point which is not connected to anything but isolated, but only exist as a part of the circuit path for the visualization. So int new pt is equal to add point, just create the same point, the same position, and then for this point I'm gonna set some group set point group. First of all, let's have a point group which indicates that this point is based on is part of the path. Okay, so I'm gonna name this a plot. Okay, and also it's a good idea to have this point a same ID as this one. So set point attrib ID. Now here it becomes more complex, and I don't know if you are following this, but hopefully you do. I am going to upload the file later, so you can rewatch this later and see how it actually works. Okay, and what else? Might also be a good idea to have a start frame value, which is this one. Okay, and as well as how it has been grown throughout the simulations, like which points belongs to which frame and so on. That might also be good information. Well, let's just not think about that later. Let's just have these as an information for now. Okay, and right now we only have points, so we do need to create the primitive as well. So let's also do that. In order to do that, we can just create a primitive using add prim as a polyline. This is going to be the actual path to be visualized. At npt. Okay, and this primitive might also be a good idea to have the same ID, so let's copy this one set prim attribute id to prim. All right, and what else? Maybe since we have other kind of primitive, which is this cross line, so there should be some groups to indicate that this path is different from these cross lines. So I'm gonna create a group for primitive, set prim group. I'm gonna name this as path. Yeah, that's probably it. And let's see. Now that I have initial setup for the primitive, and which starts from this point, same as all the other endpoints, and going back to the path growth, I'm going to also create this path, or also try to grow this path when we have found the candidate neighbors, which is somewhere around here. Okay, so right after we have picked up one of the point, we are going to grow the neighbors as well. I mean the circuit path as well. So in order to do that, we do need to first of all get the neighbor point position from this pick neighbor number. So picture neighbor pos is equal to point at pick. That's why we want to add an additional point position, which is isolated from all the grid. Neighbor position, and we want to add this point to the primitive using add vertex. Now in order to do that, we do need to know the primitive number which belongs to this same ID. So we need to find this primitive from this ID somehow, and in order to do that we could use a function called find attriv val for the primitive, and we are looking at the ID attribute. Oops. Using I at ID to search for. Okay, so if it goes well, we could find the primitive which shares the same ID. And probably it's a good idea to filter this with a path group. I don't know if the second value was the group. Let me check. Okay, so geometry. Nope, there is no group parameter, so maybe I cannot use this. Okay, so something like this. And now that I have primitive number, I can add this new point to this primitive. All right. And after I have added this new point, I do need to add several attributes like IDs, the plot group, and other kind of information. So set point attriv ID ID set point group plot. Okay, forgot the point number. Forgot this 0. Okay. Should be good. Now we have also created this visualize purpose primitive, which has the path group as a primitive group. So let's see if we can pick that up out of this for loop. So I'm gonna use the delete node and use the filter path, delete node selected. And do we see anything? Nope, we do not see anything. It's weird. I guess I am not having the primitive right here. Okay, that's weird. So this is 1182. Okay, the primitive number is not increased, so seems like there are some problem here. Let's see why. Let me check. Implicit cast from, that's not a problem. Let's look at the, okay, I'm not getting any path. Okay. Let me see. Am I doing something wrong? Okay. Wait a minute. So I have this one. Point has been added, but the primitive has not been added somehow. Although I maybe that's because I only have 1 point. How's this? Nope. Not really sure why. Not really sure why. Add prim. Let me try this outside the conditions and see if this is gonna work or not. Nope. Let me try creating the empty primitive from scratch and changing it to poly. How's this? Okay, the number has been increased, so let's, if I change to polyline, okay, I have misspelled polyline, has to be polyline. I think that's the reason. Okay, sorry for that. It's polyline. How's this? Okay, now I have a bunch of primitives being created. And now, okay, now I see this kind of weird network. Okay, this is because it is not avoiding the neighbor or visited value. We didn't create any like conditions to avoid visited points or the intersections. So the next thing we need to do is to create the conditions to avoid touching, avoid intersections. Okay, so now that we are clear, and in order to check the intersections, the things we need to do is somewhere when we pick the value and add it to the array. This is where we can add some conditions. All right, so let's do that. And so one of the condition is to check whether the picked point, in this case this neighbor point, has been visited or not. If it's already being visited, then you don't want to use that at all. So let's check that. If in point group 0 visited with this neighbor is equal to 1, then we want to skip it, meaning we can just continue. Continue means we're going to skip all the rest of the code inside this loop and go to the next iteration inside this loop. Alright, so that's one thing. And another thing is to check the intersections. Like, for example, if the point goes to this directions and if there is already a lines going diagonally like this, and if the point want to go from this point to this point, there's an intersections here. Even though this point is not visited yet, if we have this intersections, we do not want to have this point to go to this direction. So in order to check that, we're going to use the intersection analysis. Okay, so to do that, I'm going to use the intersect function. To use that, you do need to have intersection position, intersection UV as an empty vector value, and then calculate the intersection. And since we have the circuit path as a visualized path already named as path group, so we can probably use that for intersection testing. And in order to test the intersections, all you want to do, let's draw this in line. What we want to do, for example, if we have a grid like this, and since let's say we already have this lines, and let's say we want to check, okay, I don't like this, if we have a network like these, and what we want to do is to check if this okay, want to check if this point can go to this direction or not. In order to do that, I am going to create a intersection starting point, maybe a little bit offset to the checking direction, the array direction, starting from here, and then create the array like this and calculate intersections. If you find intersections, then you want to skip this neighbors. And you do the same for all the other directions until you find something that's not intersected. So to do that, the starting point should be the current point position plus a little bit of offset to the neighbor and direction. So we could make this come before and use this in the directions, multiplied by some small number like 0.2, and then create the array, which is to and pass to at P. So nPos is the neighbor point and at P is the current point positions, which will create a array like this, going from this offset point position to the end, plus a little bit of offset. It's not really a matter. Okay, and then as a result you can get intersection position, intersection UV, but all you need is whether this primitive value is positive or negative. I mean more than 0 or negative. If it's negative, you couldn't find any intersections, meaning you can go to this direction. If it's positive, if it's more than 0, then you have found intersections, you want to skip it. So if inter is more than 0, more or equal to 0, then you also want to skip this neighbor, so continue. Okay, now as a result you get something more desirable results, and I do still see some intersections right here. Let's see what that is. Okay, I'm not sure if it's doing the right intersection analysis. Let me see if things change by changing these values. Nope, not much. Nope. So maybe not these problem. Oops, what did I do? Okay, if I disable this one, oops. Okay, I think if I disable discontinue, okay, I start to have these intersections, so I do seem to have some problem, and it all seems to happens in the initial point positions mostly. So maybe I am missing some conditions for the point, which starts somewhere around here. Okay. So we need to consider that, and let's think about it. So in order to check that, I think it's a good idea to make this iteration smaller, like 1, starting to 1. Okay, it's not really changing, is it? Okay, I see the problem here. That is because since I wanted to, the reason why I have made this for loop inside another for loop is because I wanted to run the simulations one by one, not simultaneously. But since I'm using point wrangle right here, it is running simultaneously at the end, so we need to fix that. We need to fix so that this point wrangle runs on just one single point. Okay, that's what I was missing. So to pick the point, what we can do is to use this second value, iteration 2, and this iteration 2 comes from the number of last IDs, the number of IDs. So you can say that this iteration of this value can be considered as an ID value. So only if the ID, the iteration value and the ID of this point is equal, then you can run this simulations. Maybe that's the condition that I could use. So I could add another condition here. If di at id is equal to iteration 2. So in order to do that, we need to bring this outside. Now seems like everything is doing good. Although it is starting, everything is start to grow at the same time, you are getting these like straight lines for most of the stuff. So if you increase iterations, what you get is more of a straight lines because everything is starting at the same frame. So the next step is to use the attribute that I have set as start frame to have some gaps between when to start those points to start grow. Okay, so that's let's think about where we can do that. we could have another conditions to run this whole simulations to this initial conditions. If the I at start frame is less than iteration 1. Iteration 1 is the actual iteration value for the whole calculations. So that's when you can start the simulations. And now you can see that only some parts begin to grow. And if you increase this value, maybe I'm just gonna use this value here. Now points are starting to grow one by one, slowly, but as I expected. Okay, and at some point, every line has found a dead end and stopped growing, and nothing happens anymore. So that comes to the next step. When it founds the dead end, you want to respawn the point to somewhere else and start growing again. Okay, is anybody following here? I think it's really a long video for this one. I do think this is a bit complex, but well, it's kind of a mind training. Consider it as a mind training. Alright, so logic training. So what was it? Where was I? So we need to respawn the points when each line hits to the dead end. Okay, so we go back and let's see where we have found a dead end, and this is where. Okay, when there is no neighbors, that means we are at the end. So that's when we want to recreate the endpoint somewhere which is not visited yet, and then restart the growth. Okay, so let's do this. And in order to do that, we need to think about what kind of information we need to provide. Okay, so one of the information is to pick or find out the point where it has not been visited yet. So in order to do that, we do have a group called unvisited. If unvisited is equal to 1, then that means the point is not being used yet. So in order to find those point list, we could use a function called expand point group, where the point group is unvisited, which will give you a list of points which shares the same group, in this case unvisited, right? Which is pretty useful. Now what we just need to do, unvisited PTS, what we just need to do is to pick random points out of this and use it as another starting point. So we need to check if the length of this unvisited is more than 0, so that we can pick at least one. Okay, and if we have at least one value inside this unused PTS or unvisited points, we can get some random value. So in order to do that, I'm just gonna create another random value. I'm just gonna copy this one to use it as an index. Let's just copy whole stuff. Okay, at P, so let's just change these values to something different. Okay, and this should be the number of unvisited points. So unvisit PTS. All right, and try to pick the unused or unvisited PT. Unvisited PTS at index. All right. So this is the point number. Now that I have this point number, it's time to create set some new attributes and groups to this new point. So first of all, I need to set a new ID to this one. In order to do that, we need to get the last ID, then update this last ID to the new one. So last ID has been applied to the detail attribute. Like this. And for a new ID, it is going to be last ID plus 1. Okay, so first of all, let's apply this to this new unvisited point. So set point attrib 0 ID to this unvisited PT. It's a long characters. New ID. Okay, and we also want to set the group to this point as visited. Set point group visited. And unvisited to 0 because it's already been used. So unvisited to 0. What else? We also need to set the end, since this is going to be the new starting point, right? And what else? We'd also want to set the direction. So we can use this set point attrib to create the new direction. In this case, we want to make this go from top to down, top to bottom. So I'm going to use the same direction, which is 0, 0, 1, from minimum z to maximum z. All right. Now, what else? And after we have done this, we also need to create a primitive for the visualization, the path for the visualization. Okay, path primitive for the visualizations, just like we did on the initial setup. So create the new point, add point to this positions, but we haven't got the position yet. So let's get that. Vector unvisited position is equal to point 0 p at unvisited pt, and we want to create a new point which is isolated from all the grid, so it is not connected to any of the grid points, which is important. At point, and I want to make this as a part of a new primitive. Okay, so let's create the primitive as a polyline. Be careful with the name conventions or name spells. And we also want to set an ID for point and primitive. Set point attrib to this new PT and also to the primitive. That's a lot. I know that's a lot. And that this doesn't really look effective, I mean efficient, but well. And what else? That's probably it, is it? For now, I think this is okay. And we also need to update the last ID on the detail, so set detail attrib. To 0 last ID with this new ID. Okay. So how is it? Do we have... Okay, I think I'm missing the primitive group path. So set prim group 0 path prim 1. Yeah. And I am also missing the point group as a plot, which I'm not sure if I have used this, but just in case. That's probably it. Okay, something has happened, and let's see. Let me try to start from the small iteration number. Slowly starts. Okay, and I can see that this path has stopped growing at this point, and as soon as it stopped growing, it should find another point to grow. I guess this is the point where when this stopped growing, this is the new point to be spawned. Like that. And just fill up the space until the end. Okay, seems like it's working. And if I change the random seed, it is changing. Oops, I've just changed the grid Y. Just seems to work. And let's also try to change some parameters that I have set, which is this min dot and dot power. Maybe it's a good idea to promote this to this controller. Forbit and drag and drop this one and this one. So to remind you, this min dot is to define the minimum value for to compare the dot product, to compare the previous direction and current directions, the next directions. So if it's equal to 0, then you don't get the 90-degree directions. But if you have more than 0, you have more chance to have like 90 degrees and all the other all the other directions. So this is in between 0 to 1. It's pretty hard to name those stuff. Mean direction dot. It's not really straightforward explanation, but let's say. And this is a direction dot power. Not really straightforward at all. So in this case, if you have more powers, you have more chance to go straight downward, or I mean not downward, but close to the same directions, which is close to the previous directions, I mean. Okay, now let's tweak those information and see what we get here. If we make this min dot 0, you see that you no longer get 90 degrees direction, but you only have diagonal turns. If you increase more, you have more chance to have 90 degrees, and you have more chance to have more steep turn. Okay, I'm gonna keep this to point, I don't know, 0.5 or something. And if you increase this direction dot power, you have more chance to go straight like that, more like a road. If you make it really small, you have all the possibilities for all the directions. So tweak it to something you want. Maybe I like something around 7 to 8. Okay, now that looks good. Now there is one things that I don't like about the current setup is that some lines seems a bit too small, like just having 2-point connections like these, like that. For those points, at some point I want to remake it, respawn it, or just delete it. Maybe just deleting is the quickest way. Another way is to delete those smaller areas and reuse this as an unvisited area for the next iterations. But that sounds a bit too complex for this one, so for now I'm going to try to create some conditions after this grid. I mean, the sample that I created before this, before doing this tutorial, I have implemented to remove the smaller one during the calculations, during the simulations, and recreate and reuse those cleared area as unvisited again for the next iterations. But that's gonna make this code a bit more complex, so I'm just gonna upload the same file, the previous file and the file that I'm doing right now, so that you can compare those two to see what's the difference. Okay, now what I'm gonna do is to remove some of the small lengths curve after I have got these lines. So to do that, I'm going to use the primitive wrangle. And just get the number of points for each primitive, and if it's too small then just remove it. That's what I'm gonna do. So get the point list from primitive, if the length of points is smaller than some threshold, then just remove this primitive. Like that. So if it's less than 3, just remove it, and it becomes a bit more cleaner for me. I mean, for some of you doesn't really matter. Some of you, but if it comes to something like 6, you have tons of spaces left, and in those cases maybe it's really a good idea to have these as another unvisited to recreate the path. Maybe I should do that after all. Well, think about this later. And now let's say I have removed the lines which has less than 5 points, and next thing I want to do is to create an animation out of these values, out of these lines. Okay, so let's think about how we can do that. Okay, so each line has its starting frame value. Now actually newly spawned lines is missing the start frame, so maybe we can apply that value as well. So based on the start frame value, I could use that start frame value as an actual start frame for the animation. and based on the same speed we can grow this line, this curve, from start to the end. Okay, so let's apply some missing attributes, go back to the initial setup, and what we don't have for each primitive for each visualization purpose primitive, we are missing this start frame attribute. Yeah, we don't have it yet, so set prim attrib start frame, which should be the same as this value, so I'm just gonna copy this one. Right, now going back to this growth code, and we also want to apply the same start frame. In this case, we need to define what is actually the start frame, and that is actually the same value as this iteration 1, the number of iterations. This is the same as the frame value, so we can just use that. Okay, so where should we do that? That's when we create a primitive, so somewhere around here, set prim attrib 0 start frame for this primitive with this iteration 1. Right, and let's also set this start frame to the endpoint where it has found the new point, which is this one, I guess. I guess I don't really need that information, but just to make it a little bit cleaner as a data structure. Okay, that's probably it. Okay, now that I have this information start frame for each primitive, let's go back and let's try to use that information to actually create an animation based on this actual frame rather than using the solver. So I'm gonna use the primitive wrangle, and I am going to use the external function, which is still available as an official functions, but you do need to import some functions from the external library, which I have found out from some of the posts at odd force. Let me search for it. What was it called? I think it was called groom.h. Okay. So sorry, let me search this. Okay, so somewhere it has an information called, where was it? Okay, this one, this here. Adjust prim lengths from this external library, which is still contained inside a Houdini side effects Houdini, but it is not a default function that you can use out of the box. You do need to write this one, then you can use this function to carve the path procedurally or programmatically, just like these. Okay, So that's what I'm gonna use here. To use it, I'm gonna include. You don't need to install anything. You can just write this and you're ready to use the function. And the function is called adjust prim length. And the first input is the input number, and the second input is the current primitive length. Oh no, second input is the primitive number that you want to modify, and then the third input is the current length of the curve, in this case a perimeter. So we need to calculate the perimeter first using the measure node to calculate the perimeter. So the third parameter is going to be the perimeter, and the fourth parameter is going to be the new distance or the new length of this curve. If it's 0, then you're going to trim all the curve. If it's 0.1, you're going to grow by 0.1, and if it's 1, you're going to grow the curve by 1. And so if you increase this value until the perimeter, you get nice animations growing this curve from start to end. Okay, so what you need to do is to create the values for this one from 0 to perimeter based on the start frame value and the current frame value. Okay, easy as that. Let's do that. So let's say the current perimeter starting from 0, and apply this variable to here. What we want to do is to increase this current perimeter based on the frame. Okay, and what we want to do is to convert the current frame value from 0 to the last distance, last parameter, the final parameter. So in order to do that, we could use the fit function, I guess, and using the current frame value, and we can also use the start frame, which is going to be the value to start growing, and then we can create some speed. We can apply some speed to this growth, like how many frames you want to use to grow the whole stuff. Now, to do that, it might be a good idea to set the growth speed based on the length to have the constant speed. So start frame plus the current perimeter, which is perimeter, multiplied by some multiplier, which is going to be used as a frame value. Okay, and that is going to be the goal, and that is also going to be used as a speed. And then the final result that you want to get is in between 0 to perimeter. Okay, and this fit will just automatically clamp the value, so if the frame is less than I start frame, it just automatically becomes 0. So that's good. Now let's see. And nope, nothing happens. That is because I haven't set the multiplier yet. So let's say I'm gonna set the multiplier to 10 and see what happens. Okay, something happened. It is growing, and by increasing this value we can control the speed. Let's also make it real time. Oops. Now this might be a bit too slow. Seems like if I make this higher, then it becomes slower, so less value becomes faster. Yeah, that, I guess that makes sense. So maybe in between 0 to 10 works in this kind of setup. So let's make it in between 0 to 10. 100 should, is a bit too slow. Okay, nice. Nice. Now, as I said, there are some spaces left. That is because I have deleted all those small lines. So I guess I guess that it's a good idea to respawn it where it has been emptied, where it has been deleted. Okay, so I am going to, after I'm going to update the gross simulations functions right here, so that I can reuse this part where I have deleted as a new unvisited areas. Okay, and that will going to be the last things that I'm gonna do. But for now, yeah, for the final visualization, yeah, maybe I can just do it right now for that. So I'm just gonna color these first of all randomly for each primitive. It's not giving me any random values, so I am going to create a, let me check what kind of information that I have for each primitive. So I do have IDs. Alright, so I guess I could use this IDs, and I have this last ID as well. Well, I can just use this ID as a random seed. So ID. Well, it's not really pretty colors, but just to see all those different colors. And I'm gonna name this animation, and I'm also going to use the poly wire to have it a little bit of thickness. Okay, the color is gone now. I guess I need to promote this primitive color to points, attribute, promote, attribute, promote. From primitive to point. Okay. All right. So let's go back to this path growth and let's make it a bit more sophisticated. I mean, a bit more useful to use the empty spaces. Okay. So first thing to do is to think about when we need to do that. And that is when we have found the dead point. Okay. And when we have found the dead point, we need to check, we need to know if the point is the point or the polyline which belongs to this point is long enough or small, too small. If it's too small, then instead of doing all those things to create the new stuff, we can just delete the previous lines and make it all unvisited points. How's that? So let's try to do that, shall we? So as soon as it finds the dead end, which is somewhere around here, we want to check if the current circuit path which belongs to this point is long enough or not. So to do that, we need to find the primitive which belongs to this point first of all. And to do that, we need to have this primitive number which is equal to this one, I guess. So we can copy this one right here. And in order to calculate the lengths, I guess just like I did to trim out or to delete the small ones, I can just count the point numbers. So let's get the point arrays from this primitive. Let's just make a comment, delete too small. Okay, and check if the length of this point array is small or not. And that's where you can parameterize this, so min length. Okay, and this value could be the same value as this one, the remove small value. So let's also parameterize this inside this controller. I'm gonna name this min length from 0 to 10 for now. Let's make this 5. Copy this. Paste it right here. And also paste it right here. Okay, going back to where we have left. Okay, so if it's too small, then we need to set some groups to unvisited and not visited anymore. So to do that, we need to go through all the points. In this case, we don't want to actually delete the points, but we want to reset the group value attributes. For the path, we can remove it because we don't want to visualize it. I'm not sure if I can use this for loop inside here. Nope, I shouldn't use I because there's already loop right here. Well, it's okay. I think it's okay. Just in case, I'm gonna name this N. Just in case. Probably not necessary. Right, and first thing you want to do is to get the currently I am looking at the point. So this is the primitive. So I have just get the point from this primitive, and this point on this primitive is actually not on top of this grid. You know, it's just on this path and it's being isolated from the grid. But the actual point number that I want is the point on the grid. So we need to find the corresponding point number on the grid at the same position. Okay, so to do that, we could find out the nearest point. use a new point which have the group visited at this new positions, and we don't have position yet, so let's get that as well. Like this. Now that I have the point which is on the grid, not on top of the path, but on the grid, we can now set some groups to this one. So set point group visited to 0 and unvisited to 1. Anything else we need to set? We could set an ID equal to -1, I guess. Set point attrib ID to -1. Anything else? The direction, we don't really need to set anything to this one. The end is going to be set to 0 at the end, right somewhere. No, didn't I do that somewhere? Yeah, right here. So I don't really need to set the ID for that. And I guess so that's all I need to do for this points on a primitive to make it cleared up and reuse it for the next step. Now we also need to remove the primitive itself, so remove prim 0, and that should be inside this conditions. Remove prim 0, prim 1. Okay. Right. Oops. Something is missing. That is, this has to be a new point. All right. What else? What else? I guess maybe additional group that I can set to primitive that has been stopped, and that's also doesn't need to removed again. We can set the group as stop group, which we might be able to use it somewhere else. I don't know. Just a thought. Maybe not necessary, but just in case. Having all those data maybe sometimes is useful for a later usage. All right. So how's this? Let's see what's going to happen. Okay, and I don't know if we can see those things happen when the point's being deleted. Let me see from the start. Okay, I can see that right here. Check right here. As soon as it reaches to the end, and this is the length of 1, 2, 3, 4, 1, 2, 4, 1, 2, 3, 1, 2, 3, I guess. So it's less than 5, and as soon as it reaches, it's been deleted. Okay, and hopefully it'll be reused at some point. Not yet. Not sure if it's going to be reused at all. If it's not, then maybe I did something wrong. Okay. I guess something is missing, still missing. If I make this to 200. Seems like it's been deleted, but it's not been reused, I guess. Not sure. It's a bit hard to see. Okay, so for example, this line is going to be deleted. And somehow the new line has been created, so I guess it is possible to reuse it. Yeah. So probably that's good. Now I want to check if how many unvisited points are available from at this moment. So let's check that by using delete. First of all, I'm just going to delete all the lines, then pick those unvisited points. If there are anything available. Okay, no unvisited points are available. So even though there are some spaces left, so that's not really what I wanted to have. Is it? Wait, I don't see anything. Ah, has to be points. Shoot. Okay, let me go back to the. Let me increase the iterations. Oops. Let's see what I get as unvisited points. Okay, so I do have a bunch of unvisited points. Now that's good. Now let's also check the visited. Okay. That's also good. What about the end? Yeah. That's also looks good. So I guess everything is fine. It's just a matter of when to find out those empty spaces via luck, because it still is a random. Okay, so I guess everything is working as I expected. So hopefully this is all good. Let me check the one that I created before. I think it's pretty much the same. Alright. So I think it is all good. And now everything is set and I can create these animations. And I could also try with a bigger grid, like 40 by 40. And hopefully should still work. That's what's good about this parametric system or procedural system. Okay, I don't like the color at all. Let's tweak the color as well, shall we? Okay, the animation is nice. Maybe I could add a little bit of power, a bit more. And maybe I don't really want the 90-degree turn, so maybe I can make this to 0. So that I only have a diagonal turns. Okay, maybe a bit too straight. Gonna make this back to 8. And try to increase the little bit of iterations a little bit more. see if it's gonna change anything. Okay, filled in a little bit of space, but not much. Okay, well, so far seems to work nice. Now I'm gonna finish this up by changing the color and end this streaming. Thanks for joining so far. I think it has been really long today. A lot of times choosing the color for me is hard, so I use this kind of service like color to use the color palette outside. Let's say I want to use these. In order to use that, I'm going to go back to this color wrangle, and I'm gonna use the color from ramp and use that palette color to this. Somehow the color seems that it looks a bit totally different. It's too light. Maybe the gamma is a bit different. I don't know. Is it really? It's too light, isn't it? I don't know if anybody knows why the color is so different. Let me know. I don't really have an idea about these. I am guessing this is because of these color space or gamma values or something. I'm not an expert on the look dev, so don't really know much about these. Although let's just use these. Okay, now instead of using the random, I'm going to I am still using the randomness, but let's create the randomness somewhere before this color. So primitive wrangle. I'm gonna set the color based value based on the ID. Plus some kind of seed. Okay, should give you a value in between 0 to 1. And let's use that to colorize the lines. It's a bit dark. Okay, and this is, oops, where did it go? This is it. This is how I created this circuit path procedurally using a feedback loop together with the Vex. Hopefully you learned something new here, or hopefully you have followed something. You got something out of this. And if you have some comment, I'll be appreciated. And as always, I am going to upload the file that I've created and paste it on the YouTube description page or on the Patreon. You can download it freely from anywhere. And for your study later, and just use it for any purpose you want. Okay, that's it for today. Thank you for joining, and thank you for spending a lot of time with me today. I'm gonna try to make it easy one. I'm gonna try to use create the easy one next week. Alright. And I am also gonna do some more Blender ones as well, which is going to be much more easier because it doesn't have any coding contains. It's just a node. So it's going to be a bunch of nodes, but that's because without the coding. But it's also a bit good practice for me to wrap up my mind to how I can make somehow complex stuff using those limited number of nodes, which is also interesting as a puzzle. But if you want to have a serious stuff, then I always come back to Houdini. Sure. Yep. That's it. Thank you. And see you next week. And good night. Thanks you for all the comments. Night.